Thank you so much for coming. This is an important day for us. This is the first time we try this type of event, and we're very excited to welcome you to the inaugural afternoon of astrophysics. I'm Pedro Ferreira. I'm currently the head of astrophysics, and as you know, the event will be about new worlds. It'll be about the exciting work of our team of exoplaneteers, and the idea of these presentations is that these are not standard outreach talks. These are talks where we try and bring you into some of the doing of science, of the more technical aspects, but in a way we hope you'll understand. We'll have my two colleagues, Professor Suzanne Aigran and Professor Jane Burke, be giving 2 half-hour talks, and then we decided we opted for a panel discussion in the second half, chaired by our colleague Chris Lintott, and our wonderful colleague Dr. Jake Taylor will take part. And it'll be about what's happening now. And they will be grilling each other, and you can ask them some questions. So who are we? We are one of the largest astrophysics departments in the country. We have about 30 faculty. We have a lot of researchers on fellowships, postdocs. We have a large cohort of graduate students, and we have around 15 support staff, and we're very diverse and we're very active. And the areas in which we've decided to focus on, it's quite a broad spread of areas. We have people working on cosmology, i.e. the origin and evolution of the universe, the large-scale structure of the universe, many aspects to do with that. We have people working on galaxies, the building blocks of the universe, and not only our galaxy, galaxies close by, but galaxies at very high redshift. It's a topic that's become, the type of galaxies that have become very topical with the JWST. You will hear about exoplanets with my colleagues today, but we've also developed a very active area of research in transients and relativistic astrophysics, and this means things like supernova, black holes, massive explosions, accretion of stuff on very energetic objects, busy stuff in the universe. And interestingly, one of the things, you want to do all this stuff, and you span theory to observation to instrumentation. One of the great things here is we have a very active, vibrant, and important instrumentation team, which are building some of the tools for the current and future generations of telescopes. And I think these things will pop into the talks that you'll hear throughout these various afternoons of astrophysics. They really are kind of the backbone of what we're doing. But also in this day and age, it's a lot to do with statistical methods and data. And what's developed over the last decade is tremendous expertise in machine learning and data science. And so in a lot of these talks, you'll see this creeping in. We're involved in many of the current and future telescopes. And this is an out-of-date picture. This is the Vera Rubin telescope. It has the biggest cameras in the world, and it's going to make a map of the universe. Not only is it going to make a map of the distribution of galaxies in the universe, but it's going to be able to target a huge number of transients. So it's going to be a phenomenal observing machine, and Oxford plays a very important role in not only building detectors for it, but then using the science, developing the science, and extracting science from the data that we're going to collect with it. And I'm just going to throw you a very few examples of the kind of things we do. We also simulate universes, and this is one of the most, and if I could find my cursor, there it is. This is probably the most precise simulation of what the universe looked like billions of years ago. It's basically a universe in a box where you set it up with particles and gas. You started off in what we believe was the initial conditions of the universe, and you evolve it forward and you see what happens. And this involves not only gravity, it involves electromagnetism, it involves chemistry. An important part of this is it involves accurate modeling of chemistry. And you end up with this fireworks of display where, as gravity collapses and forms the large-scale structure, bits of the universe will start to light up, stars will fire up, supernova will happen, galaxies will form, and it'll lead to what we now call the cosmic web, this large-scale distribution of matter in the universe. And this is the kind of simulation that takes years to set up, because you set one of these simulations going and then it runs for months. And if you get it wrong, it's a disaster. So you really want to get it right. And this is and the interesting thing about this simulation is you're running it, and every now and then you take parts of it out so you can work on it. But then you leave it running because you're going later and later in the history of the universe. So it's a huge investment, intellectual investment, but it's been incredibly productive. A crucial part of all that is that we have very clever young researchers. And an example of how we've been able to develop that is we have an institute over in the Dennis Wilkinson building, which is that modernist 1960s brutalist building on the corner of Banbury Road and Keble Road. And for the last over 20 years, we've had a privately funded institute where we have had over 80 fellows and researchers who've gone on to be great leaders in the field. They've ended up in faculty positions in Princeton, Chicago, Brookhaven, Washington. I've got a subset of places there. And what's happened is we've been able to create a brand for people who go through this. They go through this, they're immersed with peers who are also very bright. They set up networks for life. They're allowed to focus on important problems, and they do very well in the future. And so I think this is one of the things that we excel in. The faculty does quite well. We've won a number of awards over the last 10 years, 5-10 years, and this is just a list of some of the awards we've won. But one of the things we need to do is we need to look forward, and we need to look forward, and there are two things that I would like to ask your support for, if possible. The first thing is we have the oldest chair of astronomy in the world. It's the civilian professorship. It's, I think, 419 years old. And it's currently vacant. And we have had Christopher Wren, James Bradley were civilian professors. Interestingly, Edmund Halley was not. He was rejected. But the last three post holders were George Eustathiou, Joe Silk, and Steve Balbus. George Eustathiou and Joe Silk were two of the most important characters in the development of modern cosmology. So, we had these incredibly important figures in this post. And Steve Balbus has also been incredibly important in understanding astrophysical transients. So we really get the best person for this job. And we want to carry on doing that. So we want to start looking for a new civilian professor. It has to be someone of very high caliber. And to attract someone of the highest caliber, we need to be able to give them resources. And so that's one of the things in which your support would be much appreciated. The other thing that I want to mention is, as I said, young people play an incredibly important role. We have a very vibrant graduate student program, and I put up some numbers here on the left. We typically get hundreds of applicants for a board of 10 positions, and I've split them, the positions. We can take 9 home students, UK students, and order 4, 5, or even less international students. We're very limited in how many students we can take because of funding. There are very few funding options for graduate students. And one of the things we would like to do is we would like to grow our graduate student program because, again, as you can see from the list of places they've ended up, we do very well. So, we do produce some of the best young astronomers in the world. So, if you can help us, please get in touch with me. That's a QR code. That's my QR code for my website, so you can get in touch with me. That's my email, and we will send you my contacts. And come and talk to me directly, and I'll be happy to chat with you.